Example 9 says, suppose a baker claims that his bread height is more than 15 centimeters on average. Several of his customers don't believe him. To persuade his customers that he is right, the baker decides to do a hypothesis test. He bakes 10 loaves of bread. The mean height of the sample loaves is 17 centimeters. The baker knows from baking hundreds of loaves of bread that the standard deviation for the height is 0.5 centimeters, and the distribution of heights is normal. We're going to figure out as much information as we can from this example problem. So the first thing I want to do is figure out the original claim, which is that the average height is more than 15 centimeters. So that means that the competing claim is that the height is less than or equal to 15 centimeters. Because of what we already know, the null hypothesis has to be the one with the equals. So it's less than or equal to 15 centimeters. And then the alternative hypothesis is the mean is greater than 15 centimeters. Now we know that the standard deviation for the population is 0.5. And they did tell us that the distribution is normal. So we know that the mean for our sample is 15 as well, and then the sample standard deviation, this 0.5 divided by the square root of 10, that was our sample size, is 0.16. So now, suppose a null hypothesis is true. That means the mean height of the loaves is no more than 15 centimeters. Then is the mean height, 17 centimeters, calculated from the sample unexpectedly large? So the hypothesis test works by asking the question how unlikely the sample mean would be if the null hypothesis were true. The graph shows how far out the sample mean is on the normal curve. The p-value is a probability that if we were to take other samples, any other sample mean would fall at least as far out as 17 centimeters. So the p-value is a probability that the sample mean is the same or greater than 17 centimeters when the population mean is in fact 15 centimeters. So we can calculate this probability using the normal distribution for means. And our p-value is written this way, and it's approximately 0. So a p-value of approximately 0 tells us that it's highly unlikely that a loaf of bread rises no more than 15 centimeters on average. So almost 0% of all loaves would be at least as high as 17 centimeters. Purely by chance, had the population mean height really been 15 centimeters, because the outcome of 17 centimeters is so unlikely, meaning it is happening not by chance alone, we conclude that the evidence is strongly against the null hypothesis, that the mean height, the average height, is at most 15 centimeters. So basically what this is saying is that the baker's loaves of bread are generally greater than 15 centimeters. Example 10. When using the p-value to evaluate a hypothesis test, it's sometimes useful to use the following memory device. If the p-value is low, the null must go. The p-value is high, the null must fly. So this memory aid relates a p-value less than the established alpha, the p is low, as rejecting the null hypothesis, and likewise relates a p-value higher than the established alpha, the p is high, as not rejecting the null hypothesis. So fill in the blanks. It says reject the null hypothesis when p-value is less than the established alpha value. The results of the sample data support the alternative hypothesis. Do not reject the null do not reject the null hypothesis when the p-value is greater than the established alpha value. The results of the sample data do not support the alternative hypothesis.